This is part 2 of the Linux command line, getting to know your Raspberry Pi and Linux commands. Most of these commands will work on a basic Linux system. Okay, so continuing on, we are going to do a quick review. We learned about the cat command to display contents of files. So I'm back on my Raspberry Pi. I SSH'd into it. I'm going to use the cat/proc. Remember, you can hit the tab key to automatically complete this, and we looked at meminfo. That displayed memory info. We also took a look at cat/proc CPU info. That displayed our CPU. We also can take a look at a few other things. We can take a look at the version that our Raspberry Pi is using. So let me clear my screen here. We can use cat/proc version. And that tells us the Linux version of the Raspberry Pi that we're running. We can also take a look at the partitions of our file system. So we can say cat/proc partitions. And this is a good way to take a look at the partitions, the partition number for each one of these without actually modifying anything with fdisk. We'll deal with that later in another video. But for now, we can take a look at that. You can also take a look at mount, and you can see what file systems are mounted. So the largest block is here, and we see down here that the file system extended 4 is mounted there. That's the root of the file system. We learned about that when using the command lines. And this actually is the /boot partition, and it is a VFAT. The reason why it is a FAT file system is so we can put the SD card in our Windows computers or Mac computers and read and write information to them, so we can change how the system boots. So the configuration file in the boot directory, we can take a look at it. So this block right here, it's a small partition, is created, and it's a FAT partition, so we can modify the boot parameters of a Raspberry Pi from Windows computer. So that's kind of the little association between the partitions here and what we see here. And this is the second partition, and this is where our root of our file system is mounted. This is the actual device itself. So device 0, partition 1, device 0, partition 2. That's how we read those. Alright, so you also can use a command to take a look at the temperature of Raspberry Pi. Some people like to overclock their Raspberry Pis, and you can do that with the command sudo raspy config. This takes you in. One of the first steps you should do is expand your file system. You can change your user password for Pi. You can enable or disable the desktop environment. That's the GUI, graphical user interface. Change the language and other places you're at. Enable your camera if you have one attached. Add to an online tracking system of Raspberry Pis and how they're being used. Here's your overclock option. So if you wanted to overclock your Pi or other advanced options, you go there. So I'm going to hit the tab key to go over to finish and get out of it without making any changes. So to check your temperature, if you do have it overclocked, you can use the VCGEN, hit the tab key, and it will allow you to then add a variable that you want to read. So we're going to look at the CPU temperature, so we want to type in measure_temp, and we can see that my Raspberry Pi is running at 55.1 degrees Celsius, which is warm but not overly warm. I can also take a look at what memory is being used. So in the previous video we used the command, or even in this one, cat/proc meminfo, but we can see that the total amount of RAM that's available to us, and we can see how that memory is split up between the CPU and the GPU. The CPU is the central processing unit and the GPU is the graphics processing unit. So we're going to use that VCG command. We're going to type get underscore mem space arm, and then we use an ampersand vcgen. So we're going to run the command again, and this time we're going to type get underscore mem GPU, and now we can compare the ARM memory is 496 meg, and the GPU, since I'm not running graphics on here, is set to 16 meg. So notice if we just run the vcgen command, get underscore mem arm, hit enter, it displays just the ARM or the CPU memory. So this ampersand allows us to actually run multiple commands at once. ls, and now we can see that I got basic output is displayed of the CPU memory, which it did up here, and then immediately after that it then ran another command to display a list of contents of the files in my home directory.